First, go back to the previous video to look at this slide, because we concluded the last video with this information. We related the work done by the external agent to move a charge from point A to B to the work done by the electric field moving the charge from A to B, and the difference in energy between two different configurations and the potential difference between 2 points. We did this in the previous video. So now, what if we let point A go to infinity? So now if we just substitute, we're getting, what if you want to get the work due to the external agent to move the charge Q2 from point A, but now point A is located at infinity and we want to move it to point B. And we know now the relationship of that to the work done by the electric field, and now we can relate that to the potential difference between point B and infinity. And we relate this also to the difference in energy between the two different configurations. So when the point A goes to infinity, that means RA, the distance between charge Q1 and point A, it goes to infinity. So this term becomes 0. This term becomes 0. So if we take the potential to be 0 at infinity, then the potential at point B is just KQ1 over RB. And then you can see here that the work done by the external agent is the negative of the work due to the electric field. It just turns out to be Q2 times the potential at point B, because the potential at infinity is 0. This should be potential at B minus the potential at infinity, but the potential at infinity is 0. And the potential at B is just KQ1 over RB. And we also know then how to relate this to the difference in energy between the two different configurations. What are those two different configurations? The first configuration is when the charge Q2 is located at infinity. This energy, we call it U initial. The second configuration is when charge Q2 is located at point B. And the energy of this configuration, we call it U final. Now we have a way to relate the difference in energy between those two different configurations and the work done by the external agent, the work done by the electric field, and the potential at point B due to the charge Q1. And this slide will actually be very useful when we're trying to get the amount of energy stored in a system of charges. We're going to be doing something very similar to this. We're going to be bringing charges from infinity and placing them at some points in space and trying to calculate the difference in energy between the two different configurations. So we're going to do this in much more detail in a while.